Hello there, internet strangers. Have you ever wanted to make a platformer game on Scratch? Well then you, my friend, are in the right place. This tutorial series will be covering how you can make your own platformer game, and will not only teach you how to make it, but will also tell you why it works. By the end of the video, we'll have a great foundation set for the coming episodes of this series. This is How to Make a Scratch Platformer, Episode 1. Like every good Scratch game, we start by creating a new project. Now, we need to design our game's protagonist. For now, let's keep the player's shape simple, either a square or a rectangle. Now, let's create an environment for our protagonist to explore. Create a new sprite, naming it Level, and while we're at it, rename the original sprite to be Player. Now, in the Level sprite, draw some platforms for the player to run and jump on. Once your protagonist and your level are designed, we can start coding. In the Level sprite, we'll make a quick setup script. Reset the sprite's position to 0, 0, and make it visible when the green flag is clicked. Next, switch to the player sprite. Set the player's position to a good spot on your level. I've made my player spawn on the ground. We'll layer the player on the front layer, and we'll make them visible. Now, create two new variables, X speed and Y speed, making them both for this sprite only. We're going to use these variables to move the player. So that we can test this, at the start of the project, set them both to a random value, from negative 5.0 to positive 5.0. If you were to start the project now, nothing would happen. We have to make it so that these speed variables move the player sprite. To do this, we'll make a game loop, place a forever loop under our setup scripts, and now change X and Y by X speed and Y speed respectively. Testing the project shows that the player does in fact move as we expected. However, they are going through our level walls. This is where we get introduced to the world of collision detection. The easiest option is to move the player back out of the wall the same amount they moved in, effectively cancelling our movement. This does stop us from colliding, but the player often ends up far away from the level, leaving this gap which doesn't look very natural. Most platformers on Scratch use a slightly altered system of this one. Rather than moving back the full distance the player moved in, they move back one pixel at a time until they are out of the collision. While this works, it can sometimes cause an infinite loop to happen, which breaks the game and sometimes can cause the player to get launched way out of bounds. There is a way to get the best of both of these options. We can cancel our movement and end up flush against the wall. The way it's done is surprisingly simple. Basically, we move the player in small steps, checking for collisions with the level on each step. If the player is ever touching the level after a step, we can move them back to their last valid position. This system of collision brings some extra benefits too. The precision of our collision is greatly increased, and this also prevents the player from getting launched out of bounds, because there are no infinite movement loops. Now, enough talk, let's code this new system of movement. Despite how complex it sounds, it's actually surprisingly simple to code. We'll code this in a custom block. We'll call it Move in Steps, with a numeric input called Steps. Place the script in our code. It will take the place of these change X and change Y blocks, but rather than throwing them away, let's recycle them for our scripts. Rather than moving by X speed pixels, we should divide this movement by the steps input. However, we still want to move the full distance, so we can repeat steps times to ensure that. After every movement, we'll do level collision checks with the level. Wait, what? After every movement, we'll do collision checks with the level. If these checks return true, then we'll move back to our last valid position. To do this, simply change X or Y by the inverse of X speed or Y speed over steps, like this. Let's do the same for the Y movement. Alright, there's our movement and collision script done. Just one problem. What do we put in as the value for steps? Well, we could put a constant value, but remember, we want to move in 1 pixel increments by making steps update dynamically with the player's speed. The best way to do this is to take the sum of X speed and Y speed. However, these two values could be negative, so instead, we'll add the absolute value of X speed and the absolute value of Y speed together. The absolute value operation basically just makes any number positive. This sum could still have a decimal component, which would break our repeat loop. While we could round this sum, it's better to round up, represented as ceiling of in Scratch. This is because the decimal component could possibly round down to 0 if the sum of X speed and Y speed is small enough. Plugging this into the input for our custom block and testing the project, you'll see that the player is now moving and colliding in every direction. Now that our player can move and collide, we can start bringing our character to life by adding gravity, moving, and jumping. First, I'm going to adjust my level to be a bit more fun to jump around in. Okay, looking good. Now, back to the code. The first thing we're going to do is create some very simple moving and jumping code, and then we'll organize it and make it more complex. First of all, you can remove the pick random blocks from the X speed and Y speed. Those are simply for testing. Now, let's start by adding in gravity. Change Y speed by -1 right before the move and steps block. Boom! That was really easy. Now, let's get the player moving. To do this, we'll create a variable that will track what direction the player is holding on the right and left arrow keys. We'll call it controller X. We'll set this variable to the right arrow key minus the left arrow key. The right arrow here is positive, and the left arrow is negative. This value comes out to be 1 for right, -1 for left, and 0 for no direction. Very useful. With this, we can create acceleration and friction. Change X speed by 2 times controller X, and then set X speed to X speed times 0.7 right after. Testing this, we can see that our player speeds up and slows down in a pretty realistic manner. Feel free to adjust any of these values I'm putting here, by the way. I'm just giving a baseline based on how I like my platformer games to feel. Anyways, let's code jumping. To track whether we're on the ground, we'll make a variable called fall timer. Change fall timer by 1 at the start of the move in steps block, and then set it to 0 if the player is moving down and touches the level. If Y speed is less than 0, then set fall timer to 0. Place this right after the change Y after we touch the level. While we're here, we should also reset the X speed and Y speed variables when we collide. Make sure to set Y speed to 0 after the if condition and the change Y, and the set X speed to 0 is after the change X. Now, scroll back to our game loop. We'll make it so that pressing the jump key will make us jump if fall timer is equal to 0. I've made my jump key the Z key, but feel free to make yours whatever you prefer. Finally, within this if statement, set Y speed to 11, giving us a nice hop. Now that we're done making our simple moving and jumping, we can start polishing up our engine and organizing everything. Let's start with the organization so we can make our code easier to read. Create a player X physics custom block and a player Y physics custom block. Now, drag everything related to X movement into the player X physics block, and everything related to Y movement into the player Y physics block, and make sure to put each custom block in place of the scripts. Finally, let's make our collision scripts a bit easier to read too. Create a collide X block with a numeric input of dx, and a collide Y block with a numeric input of dy. For each of the inputs, plug in the -x speed over steps block to the collide X block, and the -y speed over steps block to the collide Y block. Then attach all of the collision scripts to their respective blocks, and place the dx and dy variables into the change X and change Y blocks in the collide X and collide Y. Finally, place the collide X blocks and the collide Y blocks in the place of their scripts. With our organization done, we are now officially ready for some improvements to our physics engine. Find the player X physics block. Let's make the acceleration a bit better. Drag in an if-else block. In the if, put controller X equals 0. This is where we'll put our friction block, the set X speed to X speed times 0.7. I've made my friction a bit stronger, times 0.6 instead of times 0.7. In the else, we place our acceleration, and then we'll leave the controller X block at the top. The keen among you may notice that our acceleration is unbounded now, due to the lack of friction. However, rather than using friction, we'll add in a speed cap. Add another if-else block. In the if, check to see if X speed times controller X is less than 6. If it is, we'll accelerate the player. After we accelerate them, we'll place another if. If X speed times controller X is not less than 6, then we'll set X speed to 6 times controller X. In the else now, if X speed times controller X is greater than 6, we decelerate them. Change X speed by -0.5 times controller X. This code makes it so that the player accelerates to 6 pixels per frame, and if they ever get more than 6 speed, they decelerate back to 6 speed. Testing this, you can see that the player never exceeds 6 speed in either direction, no matter what combination of left and right presses we do. Next, find the player Y physics block. We can do some major overhauls here, the first of which will be to our very simple jumping code. Currently, we can only jump to one height, which isn't very fun. We want the player to be able to control their jump height to the exact height they want. To do this, we'll create a jump timer variable, get yet another if-else block, and replace the current if with it. Keep the when jump key press block here, but remove the fall timer equals 0 block. In the else, place a set jump timer to 0 block. Next, get 2 more if statements, the first of which will check to see if fall timer is less than 1 or if jump timer is greater than 0. So, to start a jump, we need to be on the ground or in the middle of a jump. The second will be our jump duration. Check if jumping is less than 5. If it is, then set Y speed. Finally, change jumping by 1 after this final if check. I've changed my jump height to be 10 instead of 11 because of the increased jump length. This new jump does make a small bug. Find the collide Y custom block. Make this if Y speed is less than 0 into an if else. In the else, place a set jump timer to 9. This makes it so that jumping into a ceiling cuts short the player's jump. If we didn't do this, the player would stick to the ceiling for a bit, as you can see here. Now, let's playtest what we have so far. Playtesting this makes me realize that the player is very floaty. While we can adjust the player's downward acceleration, that isn't all there is to it. Some games actually change the player's horizontal and vertical speed very slightly to make it easier for the player to execute what they want. We can do some of these in our game, the first of which will be to reduce the player's vertical speed when they release the jump key. In the else of the when Z key pressed block in our player Y physics block, check to see if the player's Y speed is greater than 0 and that jumping is also greater than 0. If both of these are true, set Y speed to be Y speed times 0.6. Place this in our scripts before the set jumping to 0 block, otherwise it'll never be true. This reduces the player's Y speed slightly if they are just releasing the jump key. Next, let's change gravity a little bit. Some games make the player fall a bit slower at the peak of their jump. This gives the player more airtime and height, allowing for them to make jumps a bit easier. In our player Y physics block, check in an if-else block if the absolute value of Y speed is less than 2. If it is, only change Y speed by negative 0.75. Otherwise, change it by negative 1.5. This is optional, but I like to make it so that this effect only happens if the player is holding the jump key. Now, for one final addition before we end off the episode. Let's make this engine a bit more customizable. Let's create a list, for this sprite only, and call it Player Physics Data. We'll look for things we want to customize, and we'll add them to our list as we go. I'd recommend leaving a comment on your project so you don't forget which item is for what. You can make these in any order you like, just make sure that all of the values are set to that list item. I'd recommend double checking. I almost missed one myself. And as the final cherry on top, let's set jump timer and fall timer to 9 at the start of the project. And that is the end of today's episode on how to make a platformer on Scratch. Sorry that this video is a bit late, making tutorial videos is a bit more difficult than I thought. If you don't want to miss the next tutorial, consider subscribing so you get notified when it comes out. In the next episode, we'll focus on the much cooler stuff. An infinitely scrolling level with only 4 clones, making a scrolling camera with a really neat trick, and improving our collision detection to handle more diverse environments. But it's good that we got this foundation for our platformer. You know what they say, every good tower needs a strong base. Anyways, have a good one, and I'll see you all later.